Hi, this is Craig Walls. Just a little bit of introduction. Many of you probably know me as the author of Spring in Action, but more recently my endeavors at SpringSource have included being the project lead of Spring Social, which I've been working on for just over a year now. So what we're going to talk about today is socializing your applications, what this means, and then some of the challenges that go with creating an application that integrates with various social networks and service providers. We're also going to talk about Spring Social specifically and how it addresses some of those challenges. We're going to have a brief demo of one of the examples, one of the showcase sample examples that we have with Spring Social. We're going to talk a little bit about how you can get involved and contribute to Spring Social, and we'll wrap up with Q&A. So if you have some questions, start thinking about those and posing them, and we'll answer them at the end. Socializing your applications. Why would you want to do this? Well, there's a lot of good reasons. There's a lot of opportunity. I mean, one thing that's not said on this slide is working with social networks is fun. It's something your friends and family recognize. If you say, I'm writing an app that integrates with Twitter or Facebook, most everybody understands immediately what you're saying. But more specifically, when you think about developing apps that work with these providers, think for a moment that Facebook recently announced that they have 800 million users now. That's a really large number when you think about it. It's if Facebook were a country by population, they would be the third largest country behind China and India. And they're expected to reach 1 billion users by spring of 2012. Now, this is a pretty big number, but it's really a small fraction of the Earth's population. At the same time, it's a rather large fraction of the connected population. So when you think about it, when you're developing an app that integrates with Facebook, you're developing an app that touches a lot of people on the internet. There's also 100 million active Twitter users. You may have heard some numbers saying that there's 200 million, maybe more than that. Recently, Twitter announced that they actually have, by their count, 100 million active Twitter users. These are people who are actually posting tweets, sharing their thoughts and ideas on Twitter, as opposed to a much larger number of users that are just lurking, that are just reading those thoughts. So yeah, they have 100 million people actively involved in Twitter, but a much larger number of people who are visiting Twitter may not actually be posting anything, but they're still reading what's there. So again, this is another large audience. You can also look at other networks like LinkedIn, very, professional network. I believe the number of users there is around 100 million as well, and as well as other things that you may not even consider to be a social network, and maybe they're not really social in as much, but they do offer some opportunity for you to build applications that integrate with them. Things like TripIt. TripIt has some social features with it, but many people just think of TripIt as a means of organizing their travel plans, or something like Netflix. Doesn't really have any social features at the present, but nevertheless, integrating with something like Netflix, integrating with something like Twitter or Facebook, very similar activity. Now, nearly 4 in 5 active Internet users visit some sort of social network or blog. And according to the recent Nielsen report. And so these are opportunities for you to inject yourself, inject your product, your application, your service, what have you, into these users, these Facebook users, Twitter users, whatever, inject into their social network. And you can do this to build or reinforce brand loyalty. You can start listening for and reacting to customer opinion. I've actually seen and heard stories about where companies are watching for what people say on Twitter and reacting to that. I've heard stories of where the data that points that they pull from customer opinion that's tweeted is far more valuable than what they may get from traditional research and surveys. You can also drive qualified traffic to your site or product. And what I mean by that is if a friend likes a certain product, there's a greater chance that you're going to link through and click on that and perhaps perhaps purchase that product as well. And finally, enhancing a user experience. Certainly, Facebook is a great place for people to go hang out and interact with their friends and whatnot. And perhaps your application or your site also has some services that they enjoy. But when you bring the two together, what you have is an opportunity to enhance the experience at both of these locations. Now, most services that we talk about provide some form of REST API. Anything that considers itself a social network almost exclusively, without any limitations, they do offer some REST API, as well as some of these other things we don't consider social networks. They often offer a REST API. Working with these is just as simple as working with any REST API, except that when you go from one network to the next or one provider to the next, you're dealing with different concepts. So Facebook, for example, Facebook has a notion of a photo album. This is something that really doesn't make sense in the context of TripIt or even Twitter. We don't have notions of photo albums. And so you have to get to know the different concepts across each one. It may also be challenging sometimes to work with these URLs. Some APIs are fairly simple to work with. One example is the Facebook Graph API. It's a fairly intuitive API to work with. Other APIs are less intuitive, a little bit more involved. The data comes back in different formats. It may come back in JSON, it may come back in XML, and ultimately, these are not necessarily the formats that you want to work with natively. You want to work with some Java object, something that contains the user's profile, contains a tweet, and encapsulates that as opposed to working with the JSON directly. And there's different error handling. Each one of them deals with the errors in different ways. Some of them base it entirely upon the HTTP status. Some provide some sort of error message. The different error message structures will vary. And in some cases, these errors that you get back from the providers may not even be accurate at all. And you have to dig a little deeper to figure out what went wrong when something goes wrong. And so it can be kind of challenging working with these APIs with all these factors in place. Another challenge you might encounter when you're working with these APIs is the security. It's not like a traditional web service where you just simply have a consumer in some service and the consumer, assuming it's authenticated with the service, has full access to everything that service provides. Instead, when you're dealing with these social networks or these other similar service providers, what you're dealing with is a situation where the application does, in fact, need to authenticate with the provider, but when it's granted authorization to perform certain functions, it needs to be granted that authorization on behalf of a user. The user has to get involved, and the user has to say, yes, I do allow this application to post a tweet on my behalf or to read my Facebook wall, things like that. And most of these providers accomplish that with a thing called OAuth. Now, OAuth itself can be quite challenging for many reasons. First off, there's 3 distinct versions of OAuth. There's OAuth 1.0, which is implemented by a handful of providers such as TripIt, Dropbox, and Netflix, and MySpace, and as well as a few others. OAuth 1.0 is the original OAuth, of course, and although it worked fairly well, there was a fairly significant, although quite honestly difficult to orchestrate, security hole in it. OAuth 1.0a came along to plug that hole. Twitter, LinkedIn, Evernote, Yammer, and others as well implement the OAuth 1.0a standard. Even though OAuth, you shouldn't be terribly concerned, even though TripIt and Dropbox and these others implement OAuth 1.0, they've also taken additional measures on top of OAuth 1.0 to mitigate the risk, as well as just simply realizing that the risk involved is akin to sharing your username and password anyway, so orchestrating it would be difficult. And these providers have put on their roadmap to move to OAuth 2 at some point. Speaking of OAuth 2, well, OAuth 2 completely revisited the entire OAuth process and pretty much designed it from the ground up. There are some similarities with 1.0, but largely it's different. Facebook, Google, Foursquare, and many others are on OAuth 2, and many of the more traditional OAuth 1 providers are planning to move to OAuth 2. The reason most of them haven't moved there yet is because OAuth 2 is not final. And in fact, as of this weekend, there were 22 drafts of the specification, which when you add it all up, OAuth 1.0, 1.0a, plus the 22 drafts, conceptually there are 24 different varieties of OAuth. And we're going to see that each one of these drafts varies slightly, just slightly, between each other in OAuth 2. So knowing which provider you're working with and what version of OAuth 2 that they implement can be a challenge, and you need to sort that out as well. Now let's take a step back and let's look at OAuth 1.0 and let's see how it works. OAuth 1.0 starts off with a REST call from the consumer application to the service provider. The consuming application requests a request token. And this request token, it's an unauthorized request token. It really can't be used for pretty much anything other than to later on retrieve an access token. It states intent, that I intend to go through this process of getting an access token. consumer then takes that request token along with some additional information, a client secret and a client ID, and creates a request. It redirects the user to the provider's authorization page, where the user gets to step in and say, yes, I do allow this, or I don't allow this. And it looks like this in the case of Twitter. So Twitter says, I'm asking you, do you want to authorize SpringSource Showcase to use your account? Here's the things that this application wants to be able to do, and you either say yes or no. If the user says yes, authorize this app, well, then the provider will redirect the user's browser back to the consuming application, from which the consuming application will make another REST call, taking the request token as well as a verifier that it may have received in the case of 10A. There is no verifier in 10, but in the case of 10A, it will take that verifier, request token, the client secret, produce a request, and ask for an access token. The provider will return an access token to the client, and then the client can then use that request token as it signs requests going to the provider's API. Now, what does those requests look like? When it comes to signing a request in OAuth 1, it's kind of tricky. You have to start by constructing a base string. You take whatever the HTTP method is, whether it's GET or POST or what have you. You take the URL for the endpoint. You also take the body parameters or query parameters. If it's a put request or a post request, you certainly take the body parameters, assuming they're URL encoded or form encoded. You take those, you take the query parameters, you sort them, and you concatenate these all together, separated by an ampersand. Well, so far so good. This is fairly easy to do. You also have to do a little bit of encoding along the way. But once you've done that, you then take the client secret that you were granted when you registered your application with the provider, as well as the token secret you got when you got your access token. You concatenate those together with an ampersand. Next, this creates a signature key. You use that to encrypt the base string, and now you have a signature that you can use to sign the request. And you use that signature in an authorization header, as you see here. Now, the authorization header has more than the signature in there. It also has a NOT. It has a timestamp. It has the consumer key itself. It has a lot of other information in there. And it's important that you get these things right. If you don't, the provider will reply with a HTTP 401 and say, nope, sorry, you can't do that. And this is terribly difficult to debug as well. Certainly by the time the signature is encrypted in signature form, it is no longer the base string, this can be terribly difficult to debug, and certainly tricky to get right. And if you get it wrong, it's hard to figure out what went wrong. In contrast, OAuth 2 is much simpler. OAuth 2 says, what we're going to do is we're not going to have a request token. That didn't seem to be a necessary concept in OAuth 2. What we're going to do instead is we're going to immediately redirect the consuming application, the user's browser, to the service provider's authorization page. And in the case of Facebook, it might look a little something like this. Facebook has various forms of their authorization page depending on what kind of access you're asking for. And they're about to change it. They're going to change it to provide a little bit more information in the coming weeks, but currently this is what it might look like. The user says, okay, yes, I want to allow this. And at that point, the user's browser is redirected back to the consuming application with an authorization code. At this point, the consuming application takes that authorization code, takes its client ID and secret, and creates another request, a REST request on the back end, back to the provider, and exchanges it for an access token. Well, the access token is given back as well as potentially a refresh token. We'll talk a little bit more about refreshing in a moment, but potentially a refresh token comes back as well. And now it can use that access token to access protected resources. Now, just like OAuth 1, those requests for those protected resources need to have an authorization header. But in OAuth 2, it's quite a bit simpler. First off, you just simply put the access token directly into the authorization header. There's no encryption, there's no concatenation, there's no base string. You just put it in there. The idea is it's strongly encouraged that the providers only support this over HTTPS for security reasons. But the one thing here is between the drafts, this will vary. So in drafts 1 through 9, you're going to see an authorization header that looks like that with the token and some token attributes set to the access token. Draft 10 has a slightly different format. Draft 12 and 13 have this bearer in all caps. and then drafts 14 through 22 have bearer in mixed case. Now, I don't mention draft 11 because draft 11 was sort of a, well, let's just say it was a draft of a draft, and it had that section of the draft was strangely left empty. So we don't know what draft 11 had in mind there. We can only assume they meant the same as 10, but regardless, I know of no providers who implement draft 11, so it's really not much of an issue. But regardless, you have these different formats, and so when you're dealing with a provider, you not only need to know what draft of OAuth 2 that they're implementing, you also need to know how you're supposed to put together that authorization header for that provider. So you're going to have to sit there and do some bookkeeping and manage which one of these drafts you're dealing with. Another challenge you have is that once you've got this access token and perhaps refresh tokens or access token secrets, you're going to need to store those things long term. There's no need in bothering your user to authorize an application that they've already authorized if they come back tomorrow to use your application, for example. These tokens, at least in OAuth 1 and OAuth 1.0a, typically do not expire unless the provider has added some additional feature on top of it, and I know of very few that have done that. In OAuth 2, it's optional. They could expire if they want to. It's up to the provider to decide if they want to support authorization. But if they do expire, then the spec says that they should provide a refresh token that can later be used to get a brand new access token should the original access token expire. So these should be stored for long-term use so you don't bother your user with authorization again. They've already authorized. In the case of OAuth 1 or OAuth 2, you don't want to bother them with that. You just simply want to keep moving forward and using the authorization they previously granted. So you're going to have to build something into your application potentially to store these for long-term use. Also, another challenge, another feature that some applications have chosen to add is signing in via a provider. For example, Twitter and Facebook, as well as LinkedIn, I believe, offer a sign in with Twitter or sign in with Facebook option. And these are great. Gives the user the ability to use their Facebook or Twitter identity as their credentials on your application. But the way they're implemented is somewhat provider specific, and they're limited to the providers that offer this feature. There may be some provider out there that simply does not offer this feature, but you might want to use it. You might want to take advantage of the fact that they're signed into another network already and just automatically sign them into your application. So what we need is a more general sign-in strategy, something that's consistent across all providers. And that brings us to SpringSocial. SpringSocial addresses these issues. SpringSocial is an extension to the Spring framework that, here, as it says, enables connectivity with software as a service providers. Again, I'm using the phrase software as a service provider here more generically than social network because not all providers are necessarily social networks. It offers features such as an extensible connection framework. This is the part of the framework that deals with the handling of connections, obtaining the access tokens, and ultimately persisting those tokens for long-term use, as well as making those available when it's time to consume an API. Also, it offers a Connect controller. The Connect controller is a Spring MVC controller that has a handful of endpoints on it that deal with the web front-end piece of the authorization phase. So if you think back to the OAuth 1 and OAuth 2 slides where we walked through the step-by-step of how this works, the Connect controller's job is to deal with the redirection to Twitter or Facebook and also deal with the callback that has those verifiers or authorization codes. At the end game, Connect controller will take the connection it gets and store it away for long-term use. There's also Java API bindings for various providers, including Facebook and Twitter, so that you don't have to deal with the APIs natively, as well as handling things like error conditions and whatnot, any oddities that may come out as a course of using that API. The API bindings address those. And then finally, there's also a sign-in controller that uniformly handles provider sign-in, not just for Facebook and Twitter, but for any of these providers that support OAuth 1 or OAuth 2. SpringSocial is broken down into several projects. There's SpringSocial Core, which includes the connection framework. It also includes the web side of SpringSocial, which is the Connect controller and provider sign-in controller. Internally, at a lower level, it also offers some OAuth API. So if you wish to work with OAuth at the low level, you can, although it's not really required. It is offered there. It also offers several provider-specific modules, such as Twitter, Facebook, LinkedIn, TripIt, GitHub, Gowalla. Twitter and Facebook are the ones that are most completely fleshed out currently. They both offer a connection side of things that can plug into the SpringSocial core to handle the connection framework pieces, as well as a fairly complete API binding. The other modules, LinkedIn, TripIt, GitHub, and Gowalla, they have the connection piece in place. The API bindings are still rather slim at this point, but we have lots of opportunity to grow those going forward if that's something that people are interested in. Finally, there's also the SpringSocial Samples project. Samples has 7 sample applications based on SpringSocial that you can look at. There's SpringSocial Showcase, which we'll see here in a moment. 2 varieties of Quick Start. There's a movies sample that uses that demonstrates how you can use SpringSocial with a API to build a new API binding. So in this case, it's using the Netflix API binding. Creates a Netflix API binding to consume the Netflix API. There's a Canvas example that demonstrates how to use SpringSocial within a Facebook Canvas application. A twr-dt-gs example, which shows how to use an API binding that's not part of SpringSocial, something that is provided outside. So rather than using the SpringSocial Twitter API binding, you may prefer to use the twr-dt-gs API binding. And finally, there's a pop-up example that demonstrates how to do the authorization phase, the web piece of the authorization steps, using pop-ups as opposed to just a general browser redirection. The key components of SpringSocial are this. There's connection factories. Surprisingly enough, based on their name, you might think that they create connections, and that is what they do. They create connections with the providers. And one of the things that the connection factories know how to do is deal with the back-end steps in the OAuth process. So if you think back to those slides, there's a couple of places where REST calls were being made from server to server to get things like a request token or to exchange for an access token. Well, the connection factories know how to do this. They also know how to create connections that are being restored from long-term storage. Connect Controller, it orchestrates the web-based connection flow. It deals with the front end, the redirect to the provider, as well as the handling of callbacks from the provider. The connection repository, this persists connections for long-term use. This is, again, you don't want to keep bothering your user to authorize. You just use what you've already got. So the connection repository is where these things are stored. Connection factory locator. Connect Controller, as well as other components, needs a way to identify a connection factory and to get it based on some ID. So Connection Factory Locator is effectively a registry where you can put connection factories, and then they can be looked up by their ID, such as we'll see later how Connect Controller uses it to look up an ID for Twitter when it's needing to deal with the back-end interaction with Twitter. And finally, Provider Sign-In Controller. I mentioned this already. Provider Sign-In Controller handles the sign-in with provider scenario. It's very similar in how it works with the Connect Controller. The only difference between it, or the primary difference between it and Connect Controller, is that the end game of Connect Controller is to have a connection that's persisted for long-term use. The end game of Provider Sign-In Controller is to take a connection that you've just received, compare it with a connection previously received, and if they match, automatically authenticate the user into the application. Also, there's the API bindings, which, again, free you from dealing with the API natively. You can deal with them at a Java level. So the key steps that you're going to do when you're adding SpringSocial to an application is you're going to configure the beans involved for SpringSocial. This includes the connection factory locator and one or more connection factories. You're going to need to also add a connection repository, a Connect Controller, and then you're going to declare the beans that are the API bindings. So first, oh yes, and you also have to create the connection status view. So when Connect Controller is doing its job, it's going to need to display certain status pages. It doesn't actually display those, or it doesn't provide those pages for you. You have to define those as best fitting for your application. What Connect Controller will do, however, is define pieces of data that it places into the model that your views can use to display whether the application is connected or not. And then you inject and you use the API bindings. So here we're looking at a connection factory locator bean. We're using the Spring's Java-based configuration, although this is it's entirely possible to do this in the more traditional XML-based configuration. But I'm showing it here in the Java-based configuration. So what we do is we create a connection factory registry. This is the implementation of connection factory locator we're going to use. And then we register 2 connection factories. We're adding a connection factory for Twitter and one for Facebook. And in both cases, when we create these connection factories, we're giving it the consumer key and consumer secret that we got when we registered our application with the provider. Now, the terminology is a little different between Twitter and Facebook. The OAuth 2 terminology is typically consumer key and consumer secret. Facebook uses the terminology client ID and client secret, but conceptually they're the same thing. It's something that identifies your application uniquely to that provider, as well as a shared secret that's going to be used in signing of the request. Here we have a connection repository. This is where we're going to store those connections for long-term use. Ultimately, Connect Controller will use this to store those connections. As you can see here, the bulk of this method is using some Spring security code to figure out who the current user is. Now, we're not going to require that you're using Spring security to secure your application. But in this sample, that's what we're doing. Ultimately, though, if you look at that last line, what we're trying to get to is, who is this user? What is the thing that identifies this user? And what we have there is authentication.getName, which is how we figure out who the current user is with Spring Security. And we use that identifying piece to create a connection repository from another bean called Users Connection Repository. As for that Users Connection Repository, here's how it's defined. It's defined simply as a JDBC Users Connection Repository. We give it a data source so it knows how to get to the database. We give it a connection factory locator so it can look up connection factories as needed. And we have to give it an encryptor. In this case, we're giving it a no-op encryptor. For development purposes, that's perfect. For production purposes, you probably want to use a stronger encryption model. Regardless, you have to give it some encryptor. Now, a couple things to point out here. If you take a look at the connection repository bean at the top, notice that it's scoped as request scoped. This connection repository bean is specific to the current user. That's why we're creating this connection repository based on the current user's authentication name. So we're creating a connection repository specific for this user, so when it comes time to persist its connections, we're persisting a connection for this user. We know exactly who to persist it for. Meanwhile, the user's connection repository is a singleton. And it is effectively, if you want to think about it this way, it's effectively used as a factory to create these connection repositories on behalf of a user. Another thing to point out here is the implementation of the connection repository we're using, of users connection repository we're using here, is JDBC users connection repository. SpringSource currently only implements a JDBC-based connection repository. We realize that maybe that's not fitting for everyone, but it does fit the bulk of the cases. We do, however, if you think about it, it really is based on an interface called Users Connection Repository. So we do, however, have some other implementations out there worth considering. The community that we have has developed a JPA-based connection repository, if that's the kind of thing you want to use. And then the Spring Android project, a separate project, they have an SQLite-based connection repository you might want to look at if you're developing Android applications that are going to be using Spring Social. Here's how our API bindings get created. So what we have is now that we have a connection repository that is specifically tied to the current user, we can create a request scope bean for both Facebook and Twitter. The Facebook and the Twitter interfaces define the top level of those API bindings. We get them by asking the connection repository to find us the primary connection that can give us those interfaces as their API binding. So we're saying, hey, connection repository, is there a connection established that can give us a Facebook or that can give us a Twitter? If there is, we'll ask it for that API, and that's what will be returned. However, if there is no such connection, in this case, the way it's wired up, we'll return a default implementation of Facebook template or Twitter template. Ideally, the Facebook template or Twitter template that's returned from the get API method call, that's the one you want to use because that's based on a given connection. It has all the knowledge of how to deal with OAuth and how to sign those requests, and so you can use it to access those resources on behalf of your user. However, if there is no connection to be had, you can still access some resources. In the case of Twitter, for example, you can still do searches across Twitter. or you can access the public timeline with Twitter, even though you haven't signed in as a user yet, or this hasn't been given authorization for a specific user. Now here's how you wire up Connect Controller. Pretty simple. Create a new instance of Connect Controller, and it requires a connection factory locator that it's going to use to look up a connection factory by its ID, and a connection repository that it's going to use ultimately to persist that connection for long-term use. And then when you're ready, here's how you might use those API bindings. And we're going to see this in action in a little bit when I run through the demo. We have basically a Spring MVC controller here that is injected at construction time with a Twitter object. So again, this is the Twitter object that was given to us when the user, given to us from the user's connection repository, or I'm sorry, from the connection repository specific to this user. And so when we get around to handling the /Twitter/tweet post message or post request, we can take and post a message to the timeline operations.update status. Note here that the Twitter API itself is broken down into sub-APIs. Twitter offers several hundred operations we could do, and rather than have that Twitter API, that Twitter interface just full of methods to work with, we've broken it down into smaller sub-APIs. So here we have the timeline operations from which we can call update status, give it a message, and that will post effectively a tweet to Twitter on behalf of the user who authorized the application. Here's the Connect Controller endpoints. The first one is get/connect, and it says it displays a status connection page for all providers. Again, the page itself, the actual view defined, that's up to your application to determine how that's going to look. But Connect Controller will make the status details available in the model for you to use. The status connection page, by default, the view name it's going to use is connect/status. The second endpoint is for a specific provider, not just for all providers, but for a specific provider. So connect/Twitter, for example, or connect/Facebook will give you the model data for that provider, whether the user is connected or not. And it'll go to one of two different views. If the user has connected with Twitter or Facebook, then it will be /connect. In the case of Twitter, as an example, the view name will be connect/Twitter-connected.j or Twitter/connected. I'm sorry, connect/Twitter-connected. If they have not connected yet, then it'll be connect/Twitter-connect. And it'll be up to you to define whatever view that is using the model data to present it. On the connect view, the one where they have not yet connected, there will probably be a form on there where they can connect, and that form should post to /connect/provider. And this will initiate the authorization flow. Ultimately, in the case of an OAuth 1 provider, we're getting the request token and then redirecting to the provider's authorization page. But in the case of OAuth 2, it simply redirects to the authorization page. The next two endpoints handle the callback from the provider. So the callback in an OAuth 1 case is going to always have OAuth token in the callback, so it'll handle that and then continue by requesting the access token and then persisting any details about that connection it can to the connection repository. In the OAuth 2 case, there's going to be a code parameter. It's going to take that authorization code and use that to get an access token that it will persist for long-term use. And then finally, there's two different delete endpoints, one for deleting connections for the current user on a specific provider, and one that's disconnecting a specific connection given that provider's user ID on that provider. So walking through the flow, just kind of put a graphic to this. Spring Social Showcase will start by getting the status page, and the status page will be delivered for Twitter, Facebook, or whoever. Then, upon initiating the request, the user will click on post, or click on the form, click on a button to connect, and a post connect/provider ID will happen. Connect Controller will handle that. It'll request or it'll fetch the request token, and this for OAuth 1 or 1.0a, not for OAuth 2, of course. Then it will redirect the browser to the provider's authorization page. So for Twitter, again, it looks a little something like this. The user will click Authorize App, and that'll redirect back to the Connect Controller with either the OAuth token in the case of 1.0a or the authorization code in the case of OAuth 2. It'll exchange the request token for an access token, and it will store those connection details in a connection repository. And finally, the application can then use those details to make API calls via the API bindings. Here's what one of those connection status pages might look like, specifically the connect page for Twitter. Notice it has a form here. The form posts to connect/Twitter. So that's the connection endpoint that Connect Controller handles to initiate the flow. That'll cause it to redirect to Twitter for the authorization page. Provider sign-in controller, again, it works very similar to Connect Controller, follows much of the same flow. The end game, though, is instead of creating a connection, it takes the connection that it received at the end of the flow, compares the provider user ID that it got with a previously established connection. If a connection is found, if there's some ID that matches up, then that local user is automatically signed into the application. Otherwise, the user can be sent to a sign-up page where the user can sign up, enter their details, and then after sign-up, a connection can then be established. Notice it's configured very much like Connect Controller. It still needs a connection factory locator. It needs a user's connection repository, and it's given a sign-in adapter. Sign-in adapter is an interface that you would need to implement. In this case, it's called Simple Sign-in Adapter, and internally the details of that is that we're using Spring Security to do the sign-in. However, we're not going to tie you to Spring Security. It's up to you to create an implementation, a sign-in adapter that can handle the sign-in for whatever security mechanism you're using. It handles, again, very similar endpoints to Connect Controller. Primary difference here is that the path is /sign-in instead of /connect. Let's take a look at the demo real quick, just to kind of put a face on this. Here is the Spring Social Showcase. I've not signed in yet, so I'm going to go ahead and do that. And you can, we have the links for this. You can download this and run this yourself if you want it to afterwards. I'm signed in, so I'm going to go to the connections page. Now notice the URL here is /connect. So Connect Controller is handling this request, and it's presenting me with the status page that shows the status for all the providers. So here we see the status for Twitter, we see the status for Facebook, and I'm not connected to either one yet. I can click here to connect with Twitter, and I'll do that. Here, by this time, it has fetched the request token, and it's now redirected me to Twitter's authorization page. So I'm going to go ahead and authorize the app. It'll redirect back, and at this point, it has redirected back. It has used the verifier that it got, as well as the request token and some other details, and has by this time fetched an access token and persisted it into the connection repository. So at this point, I can do things like view my user profile. I can go to my timeline, and just for grins, just to demonstrate this, I can say tweeting from the Spring Social webinar. Post tweet. And now you can see that's been added to my timeline. Now what I can also do is I can sign out and do a sign in with Twitter. Now that connection has been established between my account and with Twitter, I can click on the sign in with Twitter button, and I'm automatically signed in without having to enter any username or password. Now what if I hadn't already created a connection? Well, if I sign in with Facebook, now it's going to redirect me to Facebook. Facebook is saying that Spring Social is wanting to do all these things, so I'll say, sure, I'll allow that. At this point, it's redirected me back and has signed me in. And the reason it worked this time is because I guess I did have a previously established connection from the last time I did this webinar. But again, it signed me in. What would have happened, however, is if it hadn't seen that that connection was made. In fact, we can demonstrate that real quickly by disconnecting. Now let's try it. I've already granted it permission, so it's not going to ask me for permission again, but it is going to say, hey, there is no account that's connected with Spring Social Showcase, so sign up. So it's pulled in my first name, my last name, and my username from Facebook. So it already knows who I am. It's already pre-filled some of these fields for me. Now I can't use that username because there is already a Habuma username, but I will use Habuma2, and I'll enter my cleverly thought up password, and now I'm signed in as Craig, and I have a user that now if I were to sign out, I could sign in again as Habuma2. So there's a little bit more we could talk about with Spring Social Showcase, but that demonstrates kind of the flow as we've talked about it thus far. So back to the slides. contributing to SpringSocial. Now, SpringSocial does a lot of things, and it does, but it doesn't do everything perhaps that you need it to do. And there's opportunities for you to step in and get involved with SpringSocial. First off, it's important to note SpringSocial is itself a social project. We encourage you. We invite you to join in and get involved and participate. One of the ways you can participate is by discussing SpringSocial in the forums, asking questions, answering questions. We've actually had a few people step in and answer questions before I even get a chance to answer them myself. And that's been great to have that discussion going on in the forums and discuss new features and ideas of how you might want to use this. If you have some ideas for improvements or if you have a bug that you found, we encourage you to visit one of the different pages in our issue tracker. We have different ones for different sub-projects, and create an issue and report it to us. Better yet, if you feel so inclined, you're welcome to also contribute improvements or even contribute bug fixes back. We'll talk about how to do that here in a second. And there's also the opportunity to create new service provider modules. So when it comes to contributing improvements and bug fixes, SpringSocial is on GitHub. So what you'll want to do, 3 basic steps here, is go to the project where the change or the bug fix you want to make is at, fork the project, make whatever changes you feel are necessary, and then when you're ready to do so, submit a pull request back to us. We'll review it. If it looks like a good submission, we'll merge it in, and now we can move forward from there. If not, if we have some questions about what you're doing, we'll certainly interact with you and we'll sort it out. You may want to create a new provider module because we've listed Twitter, Facebook, GitHub, GoWalla, LinkedIn, and TripIt. There's other providers out there. Lots of other service providers you may want to use SpringSocial with. If that's the case, you have an opportunity here to create your own provider module, and one of the ways to do that is to follow these 4 steps and make sure that when you're done, make sure it's where we can share it, perhaps in GitHub. So you want to create an API binding, service provider, an API adapter, and a connection factory. And we're not going to really tell you exactly how you design your API binding. That's pretty much up to you to decide how you want to do that. Some basic rules of thumb, some basic guidelines here. Be sure and separate the binding interface from the implementation. Just package-wise, separate them. Make sure that the implementation is more in a private area and hidden from the interface. We don't want people to, who are using your API binding to accidentally use things that were not intended as part of the public API. Just general good idea. Also, organize the API hierarchically. As I mentioned before, Twitter has several hundred, so does Facebook has several hundred operations you could perform on it. You don't want to have one big interface with everything in it. So here we've broken Twitter down, as you can see here, into several different sub-APIs, direct message operations, friend operations, and so forth. And as an example, direct message operations is defined with this handful of messages that specifically pertain to sending and receiving direct messages. When you're creating your API binding implementation, you want to consider extending abstract OAuth 1 binding or OAuth 2 binding, depending on which kind of provider you're dealing with. By doing this and creating your constructor so that it just simply gives the consumer key secret token and token secret through the super call, what you're able to do after that is you're able to call REST template in your API binding and receive a REST template that is set up to do the signing for you. In the case of OAuth 1, it makes sure that that authorization header with all the nonce and timestamp and everything is in place. In the case of OAuth 2, it makes sure that the proper authorization for the version of OAuth 2 that you're dealing with is in place. So the service provider, this is what allows users to authorize with the remote provider. Effectively what it does is the service provider knows how to deal with the remote provider when it comes to performing this back-end call to get the request token and access token. So you'll definitely want to set it up so that it knows what the consumer secret is, and consumer key and consumer secret is, and then you set it up with these different endpoint APIs that the provider defines for interacting with its OAuth implementation. In the case of Twitter, we have 4 API endpoints that Twitter defines, one for fetching the request token, one for authorizing the request token, a similar one for authenticating the request token, and the primary difference that Twitter defines between those two is that in the case of authenticate, if you're already connected, it won't prompt you. It'll just simply authenticate and move on. That's why when I clicked on sign in with Twitter, it didn't ask any questions. It just immediately signed me in. And then finally, one for access token, where you can exchange everything you got for an access token. Not all providers have the notion of an authenticate endpoint, so if you don't, there's actually another constructor that doesn't take that. You can leave that one out, or you can just duplicate the authorize endpoint. Once you have that, then you have a get API method that will return the authorized API binding. API adapters, this basically allows SpringSocial to deal with your API binding in a uniform way. So it takes whatever the native API is and maps it onto our connection model. Here's an example of the Twitter API adapter. It offers a test method for testing to make sure the API is actually working. A set connection values to set those onto a set of connection values that are specific to the connection. This is where the data comes from, in addition to the access token and refresh token or secret. This is other information that is persisted with the connection. We also have an opportunity to fetch the user profile in a standard uniform user profile object, not something that's specific to Twitter, but it's something that can be uniformly used across all providers. And finally, a uniform way of calling update status. And in the case of Twitter, it just simply goes and gets the API, calls timeline operations, update status, and uses that. In some cases, maybe it doesn't even support that, so you can leave that implementation blank. Finally, the connection factory. It brings together the service provider, API binding, and API adapter. It just brings them together into the connection factory. Once you have this, you can certainly register it with a connection factory locator, or you can use it on its own. Notice the provider ID there is Twitter. This is how connection factory registries look up a connection factory, is by that ID. So here we've given it the name Twitter. When Connect Controller is looking this up, if it has a path /connect/Twitter, it's going to find this connection factory and not something that has a different ID. I should finally mention as a shout out to some of the great folks in the community who have contributed already. There are several folks who have done an awesome job building up SpringSocial beyond what we provided out of the box. There's API bindings and connection support for Foursquare, Instagram, Yammer, Google, Dropbox, and Viadeo. Specifically, when I call out Google, the most interesting story there is Gabriel Axel, the gentleman who developed that. He had some of this working for a while, dealing with some of the other Google APIs, things like the Contacts API. He had started work on this, and just within a few days of Google announcing their Google Plus APIs, he had already built in some Google Plus support into his Google module. So that it's great to have a rich and active community who's helping us build out beyond what we can possibly do on our own. There's also Spring Security for tighter integration between SpringSocial and Spring Security module. There's some work being done there, as well as a Grails plugin if you want to use SpringSocial within Grails. And with that, I am going to turn it over for Q&A. So if anyone has any questions, now is a great time to ask them. So one question is, it sounds like provider sign-in requires an app local user already existing. Can the sign-up page be as simple as creating an app local user account, basically just the user ID? In fact, yeah, I didn't really show it in the example here, but there is the idea that you can not even have a sign-up page. You can even bypass that and just implicitly register a user based on their provider details. And there's one of the examples, the quick start examples from the samples projects, they show exactly how to do this. One of the questions, it was already answered, but I'll go ahead and mention it. Says it found the JDBC only repository, talking about doing a NoSQL solution. Well, that's true. We only have the JDBC implementation right now, but if a NoSQL solution is interesting to you, yeah, by all means, give it a shot. Submit it to us. We'd love to see it. It certainly is something I could see some people being interested in using. Okay, any other questions? I only see questions regarding the presentation at this point. Anybody got anything else? One question we got is sometimes the Facebook's Graph API is broken and it doesn't return everything it should or doesn't behave the way it should. Is this something that SpringSocial deals with? And yes. I mean, there's different ways of talking about this. One of the things is that Facebook's API historically has been quite fluid, and they've been quite welcome to making changes, even breaking changes. And they've made a policy now where they're not going to make any breaking changes, at least knowingly, without a 90-day warning. The other thing, given that, even that's certainly on Facebook's side. The other thing is on SpringSocial's side is we have broken the SpringSocial Facebook projects separately from SpringSocial Core, likewise with the other provider-specific modules, so that they could evolve and grow at a different pace than the core module or from each other. This enables us to act more quickly with regard to any changes that happen on a specific provider. And more than that, if the way the binding is written, it should be fairly resilient to missing data. So, for example, if you don't have authority to see a specific field because, for whatever reason, the user hasn't granted you that authority or you never asked for it, that field's typically null, and it's fairly resilient to those situations. If you find out otherwise, I encourage you to submit a bug, and we'll take a look at it. If two people share TR-dt accounts, how is it supported by SpringSocial? If two people have the same TR-dt account, that's a good question. I do know that we have the situation where a single person can have multiple provider accounts. I'm trying to think through the situation of what happens if there's multiple connections to the same provider account. It's a really good question. I should know the answer to that. I'm actually drawing a blank right now on how we deal with that. Is there a roadmap for SpringSocial so that I can get some indication of when and what new features will be available? There's not a roadmap per se, although you can certainly look in our JIRA our issue tracking system, and you can get some idea of where that's going. Long term, one of the things we're looking at for certain is additional ways of doing OAuth 2. There are other mechanisms for OAuth 2 other than the authorization code flow that I showed that we're looking at, such as user credentials. So whoever, rather than exchanging a authorization for an access token, you might just simply exchange a user's username and password. It's fairly specific use case for this that you probably wouldn't use in most cases, but in a case where you can trust the client to know what the username and password is, that's certainly a valid way of doing OAuth 2, and we're going to look into supporting that, as well as a situation where the application itself wants authorization, not for a particular user, but just needs to get at some application-specific API endpoints. So we're looking at also supporting that in OAuth 2. Is there a Hibernate user connection repository implementation, or should we just use the JDBC implementation? There is not a Hibernate implementation. However, typically I would imagine the JDBC implementation to be sufficient for anything that's hitting a relational database. I've heard some arguments, on the other hand, where people are saying, no, you really want to use JPA, but given the scope of what the connection repository does, I'm struggling to figure out why you would want a Hibernate-specific connection repository when the JDBC one should be sufficient, even though they're both hitting the same database. Oh yes, I failed to mention, I had meant to, but I failed to mention one of the other things that's on the roadmap is deeper integration with Spring Security. Okay, any other questions? If not, then thank you very much for your time. Certainly, if you have any additional questions, you can ask those in the SpringSocial forum. And otherwise, thank you very much, and goodbye.